Michael, can you see my screen?
Yes, I can.
All right. So thank you, Michael and Hussein, for allowing us to present how National Renewable Energy Lab is doing the digital twin. We are talking about digital twin in the control room. The operators in the control room are facing major challenges, especially renewable challenges. The renewable generation will be dominating, and more EVs are running, and possibly many high voltage DC transmission line will be built. And so imagine this scenario. During the sunset time, as you see on the right side, the way solar PV generation is ramping down fast, but the demand are increasing. And many SCADA alarms fills the control room within minutes. There's no time to acknowledge these alarms. The operators don't have enough technology to process all those alarms. They have so many displays, so many monitors, as you see on the right side. So the decision-making tool is another pain point for operators. What if you have a second operator to virtually assist you out, the filtering through alarms and identifying critical issues and presenting operators with actionable insight in real time? And this is what today's presentation is all about. We are presenting decision-making framework that help out operators, leveraging digital twin and AI as a new decision-making platform in the control room. Digital twin is a digital representation of power network model and real-time measurement and able to simulate scenarios. In the power industry, digital twin is being used several ways. The remotely monitoring asset and simulating how it behaves, or it can predict how long the asset will last or remaining useful life during the power delivery. Another case is proof of concept, when you have a new idea that you want to simulate, how will that impact? Or what if scenario that we just mentioned. This slide shows the how the control room configured. In the US, the power grid is so huge that we cannot rebuild the whole electrical grid or physical twin. 50,000 transmission substation, 12,500 power plant, and miles of transmission lines. So engineers came up with the idea of measurement and a network model to virtually mimic the grid. And then they adopted simulator concept from airline industry pilot training simulator. We call it dispatcher training simulator, or DTS. DTS is for training operator to learn how to respond if a situation happens. So DTS has been running for a long time. In other words, digital twin is not new in the control room. For today's discussion, we will focus on decision-making in the control room. As you see on the left, the power grid sends the data to control room, from generation to transmission and distribution. And several years of me supporting in the control room, and as a certified NREL system operator, to me, the system operators are the brains of the grid. The brain is collecting the data from your eye, from your ear, and then it's your brain to control the actions. System operators are the ones who make sure the power flows reliably from generation to distribution, and also has within the line limit. And so the light stays on 24/7 and 365. So to me, the operators are tug of war or power struggle between generation and the demand. In the past, the operator's decisions making is fairly routine because they mainly look for two things. One, do I have enough generation to cover demand? And is there any violation on the any limit? But things change over the decade. First, the load used to be the generation following the load because the load curve is pretty predictable. But as more PV generation from the customer, and then the EVs are adapting into electrification, now we are seeing the load is following generation, or demand response is sensitive to the energy market price. Secondly, because customers are producing the PV rooftop solar generation, it used to be one direction from generation to distribution, but now it's flowing both ways. So operators are looking for reverse power flow. Third, because of more inverter-based resources or IBR connected to the grid, which is running at the computer, so it doesn't follow the law of physics. At the same time, the many synchronous generators are retiring. So system inertias are disappearing. So these are the operational challenges. Of course, there are many external challenges like extreme weather or cyber attack, but today we will focus on normal operation decision-making in the control room. So this slide shows what tools or what procedure the operator has to follow. They have to follow the NREL reliability standard when they operate. They have tools from SCADA monitoring and control the field. And energy management system is running state estimation and contingency analysis. And then they look for all those displays to find out what's happening, how to mitigate. And then they look for the knowledge-based system for possible what was mitigation before. So why not another decision-making besides SCADA or EMS? Because the technology, when technology like hardware or software is been very limited because of, think about all those, the computation they have to go through. So decision-making was purely on the operators. So to support the decision-making, we need to understand how people make a decision. There is one decision-making model, the studying generation control room operator by Rasmussen decision ladder back in 1974. But I want to pay attention to Gary Klein's recognition primed decision, or RPD, in 1993. The model describes how individuals make decisions about difficult times under time pressure. RPD model was developed initially for the interviewing firefighters, but for today's discussion, let's be a control operator. You are monitoring the situation. That situation generates the alarms, like there's a unit tripped. You have 30 minutes to mitigate before the situation getting worse. And so you recognize the situation, and then you understand what the issue here is, a unit tripped. So you're waiting for real-time contingency analysis runs, and that's the cue. That's the one that find out, okay, what's the mitigation that adopted before. So you assess the situation, you find what's the cue, and then you find the pattern. that what was a similar case happened before. So because it's a pretty simple unit trip, and you look for a reserve planned, and you know what to do, then it's pretty simple actionable plans. Maybe automatic generation control or AGC already kicked in to arrest the frequency drop. However, if it is a new situation, so many alarms, other generations, the generators are tripped, then it may not be the right action plans. So you cannot just rely on agency to help the situation. So in that case, you run the simulation. And then if a simulation produces the right result, then you can make your action plans. But if not, then you change the input parameters or the scheduled generation plans. So by running the simulation, by changing the model, you find the right action plans. Then you give an operating instruction. It may be a generation redispatch, or it may be a load sharing. So by doing this, you make the situation calm down. RPD runs, as you see, is a mental simulation and mental model, means it all happens in your brain. But in the control room, as I explained, they have a simulation DTS. They have a operation model and a real-time measurement coming in. So you can actually run those simulation modifying input on your hand. So in this scenario, what technologies we can bring to have better decision making? So from cues and patterns, we can use AI. For simulation and then model change, that's a scenario, adding scenario, that's a digital twin. And for recommended actions, that's a display. So here's what at NREL, we have a digital twin. I will explain this first and then show the demo second. But idea here is EMS is running, and we have a digital twin able to play and stop. The one that we are going to show you is the contingency ride through. When there is a contingency that causes power flow not solving, that's an unsolved contingency. It is critical. It means the grid may run into cascading uncontrolled situation. So operators must validate or must fix that unsolvable contingency and come up with a mitigation. With the digital twin, we are able to reproduce those contingency, but the EMS reported 2 of them, but digital twin validate only 1 is reproducible. So operators can ignore the one that not reproduced in the digital twin. Then digital twin with all those generation redispatch and all those changes that able to solve the unsolved contingency. So using digital twin, we are showing how we can ride through the contingencies. It means that operators currently they have to manually do this all, but now is a digital twin you can do automate way. Okay. So here's how we architectured on the EMS is sending the cases every 5 minutes to digital twin or on demand. And then also send the power word for generation redispatch. And then power tech transient stability analysis tool for frequency nadir predictions. Okay. Now, I'm showing here that we can, when EMS is running, we can use digital twin to pause or play. And then using digital twin to verify what was produced in the EMS contingencies. And we verified 2 out of 2 unsolved contingency. We verified 1 is reproduced. And then we run through the validation state validation, and then it will bring us what the state of after digital twin adding all those scheduled changes, the generation changes. Then it will ramp up or ramp down. The frequency is fluctuating, but is within the range. Then we give them the path, past the contingency case. So you will see that the second unsolved contingency reproduced will come back with a warning. Okay. Now we have a digital twin in NREL. We are thinking how we can use digital twin in several ways. One is, as you see, the study automation. This is the current manual process you can automate. Second, as I showed, we have a contingency write-through or voltage write-through. And then because of digital twin, add the forecast and the scenarios, it can do the continuous operation plan assessment for the look ahead analysis. From AI side, I will have several slides for AI, how digital twin can help. The one is make AI trustworthy. And the second one is the digital twin give a synthetic data to AI for pre-training. And then finally, the cyber attack, if there's an anomaly, it is a cyber attack or misoperation. So digital twin can make AI trustworthy. Simply means after AI produce the recommendation, then digital twin validate its result. As NIST mentioned, the trustworthy AI is valid and reliable. And so what we are proposing here is let's use the digital twin verify what AI produced or physics informed. The second one is digital twin is able to provide the synthetic data for AI training. As we all know, the utilities will not share their sensitive data. So we have to make synthetic data. So here we use digital twin to produce the synthetic data to train AI. This is another way we can use a digital twin to detect anomaly and if it is a cyber attack or misoperation. So operational anomaly, digital twin is basically operational technology or OT, it's not IT. So OT is looking inside the measurement, inside the command, why this measurement coming this way. So if we have a good operation range on the operation guide range, then digital twin can validate the anomaly is outside the operation range or not. Or like the bottom center, you see the vision-based anomaly detection is the measurements coming in, the circuit breaker status not match up. That's what the AI can come in and find out that this anomaly is there's an anomaly in the single line diagram. Then digital twin validate, is it because of the switch malfunction or communication issue, or is a cyber attack? At NREL, we are drafting a new decision-making platform called eGrid-GPT. The reason we introduced eGrid-GPT is a couple reasons. To offer virtual support the operator through the unified platform is a comprehensive decision-making tool. Dynamic dashboard, digital twin, AI. This consolidation minimize the tools and then displays. And then also using this platform produce synthetic data to AI train. That's I mentioned before. So it is targeting secure and trustworthy and reliable. This slide shows how Eagle GPT will play out in the control room. I will not go into detail on this, but from the operators ask a question, then generative AI will process it and send a response. That response will be validated by digital twin. And then the result out of digital twin, the human informed, the operators will verify it and possibly add more scenarios. That goes into the final central repository, historian. And then right before the recommendation out, then it will check the answer is the how critical, how sensitive the answer is. Like determine that if the answer is a negative impact to power operations, then it will filter out. Then this lead into the display, and then operators choose the recommendation. The idea here is operators finally final ultimate decision maker, not the AI or digital twin. They are just supporting operators. So I will ask Risha, are you there?
Yes. Can you hear me?
Yes. So go ahead, explain this slide.
Absolutely. So far, Song talked about the importance of trustworthiness of the AI and how digital twins can help improve that. From NREL's perspective, when we look at the digital twin onboard transmission and distribution side, the slide in front of you sort of represents the high level integration of that setup. You see, there is a transmission side represented by a combination of synchronous machines, some equipment at medium voltage or high voltage being tested, inverter-based resources connected to the transmission system. And then you have a host of different kinds of resources like hydrogen, wind, industrial loads, batteries. It could also have other kinds of sensitive loads. And ultimately, we want to look at all this data together through a digital twin or maybe integrated with a digital twin, meaning a set of models which replicate the system very well. And then also look at the response of ADMS and EMS together. ADMS being the distribution management system, EMS being more of the energy management. And finally, there are computation resources which may be doing additional set of computations, analysis, and such. The point being, together, this platform or these combination of resources allows us to replicate any system with a quite diverse set of assets and stakeholders together. The idea is to look at the power exchange between them, the communication between them, and then use that to train the model where needed. And that's why you see at the bottom, the data, the high fidelity data that comes from here is used to train the encoder decoder model. Encoder decoder essentially says that think of it like a translation. You give it an input, let's say in French, and then you expect that the outcome to be in English. Similarly here, you are giving this measurement data, operational data, operator logs, whatever, as the input, and then you're expecting some sort of output in let's say as a decision or as a situational awareness question. And that's what the AI portion would be trained to do. It would take this data, format it, extract the relevant information, and then it would give you the outcome that you can then validate against how the system is operating in real time. And that helps you build the reliability and the trustworthiness of the AI outcome over time. And once you think it's field ready, then that is when you can start using it on the field and continuously improving it as needed. Thank you.
Thank you, Risha. So the one that the last one that I want to mention is a prompt-based dynamic display. This is a futuristic. This is our goal: is to provide the display to the operator that based on their prompt. So in this slide, I will show this is during the solar eclipse last month, April 8th. We had a solar is passing the eastern connection, the east side of it from Texas. So operator may ask this during the solar eclipse, animate the PV reduction and increase while ramping down up and down by other generation sources to meet the demand. Let's see how it plays out. As you see on the left, the dotted line is moving. That is showing the solar is crossing that the eastern side with the Texas first. So when it goes the valley, the map will dark out, means the solar is now totally obscured by moon. And so solar is reduced its generation, but once it passes, it's increasing. When we actually live stream this solar eclipse event, the Texas ERCOT will drop the PV for 13,000 megawatt in 30 minutes. So when that solar is ramping down, how the other generation is helping that out? As you see on the right side, the solar and the natural gas, and when you see that the map is dark, then the battery and the natural gas is ramping up. So the idea is the operators want to see this in their prompt instead of finding out where the display is. So ask a question, then this display dynamically show up how the PV the ramping down and ramping up, and then the other the generation resources is compensated. That's what you're seeing this, and that's our vision for display. Okay. So to make that happen, the digital twin, then operators ask a question, then we'll bring up the orchestrator. The orchestrator, based on the questions, that it will create its own workflow. It knows which tools to bring, what code to write to make your input successful. And then by utilizing the AI model, get the recommendation back. And then it will show the display. And based on the display, the recommendation, the operators will talk to other the energy domain, other domain, interdomain operators like natural gas or telecommunications. This slide sums up the presentation. This picture is about a century ago from Los Angeles Department of Water and Power. The one operator is on the telephone, while other operators calculating load redispatch numbers. So around the world, that you see the line diagram and the meters. But in the future, we want the virtually assisting AI digital twin, hopefully that a robot is helping the operators. This is what we are seeing, that why the digital twin and AI is the key for a new decision-making platform. This is the final slide, that we see digital twin as an automated simulation and reduce the manual process, and then adding scenarios. So that will bring more better decision-making. And AI as a virtual assistant, and they give the recommendation what the human before was ignored, maybe give something meaningful to them, and orchestrate the tools in the control room. And then the display will dynamically respond to what operators request. So by combining digital twin, AI, and advanced display, in the control room decision making will be better and physics informed and then trustworthy and explainable. Thank you. Any questions?
Thank you, Mr. Show. I guess we already have the first question a few minutes ago from Sanjeev. So the question is, what is the digital twin development platform? And how would you validate the control room digital twin model with different vendor software setting in control room at the same time, given that various models exist in each region, grid, EMS, and transmission operator?
So we have the digital twin based on G or some EMS. So we use that as a base. And then the model, operation model is the peak reliability coordinator 2019, the WEC, the Western system model we call the WSM. So we have a full Western interconnection model. Now we are moving into SPP and Eastern interconnection. The operation model, I mean, planning is already there, but the operation model. So using that, the real EMS, the commercial vendor platform, and the real operational model. That's how we make up this. That answers?
Sanjeev, do you want to add or any additional
Yeah,
questions on
thanks,
that part?
Dr. Sung. Yeah, thanks, Dr. Sung. That kind of answers me. I'm still wondering, like, because I worked a little bit on the GEMS software, but most of them are kind of a steady state analysis. So how do you visualize these maybe the dynamic scenarios? Because right now you're looking at the solar variations, ramp up, ramp down, how does impact the different plant operations, maybe kicking the AGC. So how do you realize those kind of scenarios in the EMS platform?
So, yeah. Okay, go ahead, Risha.
I can just add to what Song said, Sanjeev. I think in our mind and what we want to present is that it's not necessarily a steady state or a transient domain problem as such. It is more of a use by use situation. So, for example, in this case, when you say it's not like we are only using the EMS or the steady state solutions. The idea of the digital twin would be to be able to replicate if it can validate the situation in the given time domain. For example, if you wanted to emulate or make a decision on transients, right? If there is a digital twin which can reliably replicate that and then inform the AI, and then AI can actually consider that in the decision making process and respond back to the operator in real time or in the needed time, then that is a feasible option. With the current situation, these things are usually slower in the order of seconds at least, if not minutes. So which is why we are currently looking at EMS and other domains where you need more robust analysis. But it's by no means supposed to be tied to a specific vendor or a specific vendor kind of platform. When we train the AI to understand different formats, this would become a part of the standardized process where all the leading vendors or whatever model the utility has, they would be validating their AI to understand those nuances. So if you're using a combination of 5 vendors or 50 vendors, and that would play out in your planning as well.
Yeah, thanks, Rishabh. That explains me. I'm just still wondering what kind of output format you're using. Is it like same kind of format or any common format you define to be a vendor agnostic, just to make sure like it will be compatible with any vendor EMS software, not only the GE?
That's correct. So because of National Lab, we are vendor agnostic. We just use GEMS, but the input and output of it all so basically JSON format to handle the interoperability between the vendors. Does it answer yours?
Yeah, thanks, Dr. Sir. Thank you. It's a great presentation. Thank you.
Thank you. We have a couple more questions in the chat. Gian, if you want to go unmute and ask your question.
Yes. I was asking in this process, first, this is a very good presentation. So in this process, if the inertia of the system is going very low with a lot of inverter-based systems, so how do you consider of using the EMT-based simulation to complement the phasor mode simulation?
Should you, Song, do you want me to take it? Or
Yeah, please do. That's EMT is your area.
so, great questions, Jean. The key idea is when we look at how we initialize the models or how we initialize the different set points. It could be the sensitivity of let's say the excitation control of the generator versus maybe the write through responses or the frequency response of a specific characteristic. Those are the things that can be determined or derived from the standards or the recommendations from NERC or the utility itself or the ISO, and that would be used to make the simulation more reliable. From the operator's perspective, the key idea is that they have to run the right simulation in the right time and consider all the different factors together. So for a given situation, ideally when the operator makes that prompt, the system, the co-pilot should be able to determine or recommend the right set of relevant standards or set points that should be applicable. And if the operator approves that yes, this looks good, that is when it would become a part of the EMT simulation. And then when you run that simulation, the outcomes can then be more useful to, especially for the low inertia grid, like you pointed out, where the stakes would be, where the margin of error can be higher if you don't initialize the model correctly. Does that answer your question? Or
Yes, but so does that mean that in this control room you would have a standard phasor-based simulations plus EMT simulation for specific case? Because the controller could be quite well affected by the fast transients.
so from our perspective, we want to focus on the validation part, and because ultimately we are trying to control the real system. So if we initialize the model correctly, our responses would match what is happening in the real system. So at this point, at least to my limited understanding, the use of EMT models in the control room is very limited, maybe even non-existent. I am not sure about that. But with time, if we can initialize the model or update the model correctly to reflect what is going on in the field, we can use that in the scenario analysis that Song was talking about earlier. Because ultimately, the recommendations from the AI should be based, or really anyone for that matter, should be based on what the system is actually going through right now. So that's how we think that EMT can play a better role if over time. But it is a lot bigger challenge to correctly initialize and then run an EMT simulation, analyze it, which is why there is a bigger volume of data compared to, let's say, a steady state model. And we need to be more thorough. But that is the idea, yes.
So maybe if I add, the slide that I'm sharing is that's our vision, that adding EMT and the other tools inside the decision making, so control room operators don't have to find other tools separately. The setting up is that's what we are doing it, especially Rishabh and our teams, is the setting of the EMT in the our test bed.
Okay, thank you.
Thank you. We have another question from Danny Espen. Danny, you want to go on mute and ask your question?
Yeah, thank you. Thank you very much for the presentation. It was really interesting. I would like to know what are the computational resources that you are using to build and to run the digital twin in real time.
The one that we are using is AWS, the cloud version, and also on-premise version. On-premise somehow is lagged in terms of the hardware-wise. It's not that comparable to AWS. So we are actually using both end to set up the digital twin, and then so the computer, the memories and CPUs is pretty top notch. The compared to what I used to work at the peak reliability. That's where the physical server is actually doing the digital twin. So that it answer yours?
Yeah, thank you.
Okay.
Thank you. Any other questions from the audience?
Sorry, Michael. It's not a question though. I just want to add to Rishabh's point about the EMT models. China is using the EMT models to assist the operator decisions in terms of analyzing what kind of impacts could really cause outage scenarios or blackouts kind of scenarios. So they are using it, large EMT models, especially these RTDS-based models for the operations in EM. It's assisting. It's not direct use, but it's just assisting the operators.
So, sorry, which operators are using? You said what
It's
company?
transmission system operators.
So
I need to get more details, but I can able to give you the exact. It's in one of the centralized power research institute from the China, and they are using they're using this 22 or 30 plus clusters of the RTDSs.
and I do want to emphasize that really it's any kind of real-time or non-real-time simulator is compatible. Again, the idea is to be vendor neutral and platform neutral, because like each utility would have a specific set of solutions that would work better for their use cases or their kind of use cases. If you're talking to a cooperative, they might be even more limited in terms of what they can or cannot use. But if you're talking to an ISO, maybe they have more resources at their disposal, and which vendors work best for their system. So in this case that Sanjeev mentioned, yeah, like one country has been able to put the resources and time and workforce to develop a detailed model of their entire grid. Not every country may be able to do that, but if they are, or if they can model it sufficiently, yes, EMT would become a reasonable source of information as well. But the idea is that this platform should be, or this approach should be compatible with any set of vendors or data points. And that is the whole idea. We provide something which is foundational, and then the utility and the vendors, they adapt it to make it work for the customer who is essentially buying the setup and implementing it for their use.
Thank you. Sanjeev, do you want to add any further parts on your side?
No, I'm good. Thanks,
Thank
Rishabh.
you. Any other questions? I have more of a kind of an industrial acceptance question. How, like from an approach perspective, for your model, it seems working, but how would that be applied in real life, and how industry partners, whether transmission distribution operators, have already heard about the idea and accepted or tried even applying the same model on their side? Is there any ongoing efforts in this direction?
So when we presented this to ERCOT and California ISO, they are interested in. and then Western Area Power Authority, they are interested in this digital twin concept. But digital twin itself is just the automation. What they really want is a whole new decision-making platform, and that's where they are assessing now that they don't want just piece by piece. They want the whole decision-making platform inside, and so industry is definitely interested in it. The way that the way that show that whole control room, how the architecture, and then where is the pain point we indicated during this presentation. So they know that what we propose is readily the adaptable to their control room. It's a matter of they put the money and the resources to do it.
Thank you. Another question that I have is, you mentioned some of the applications for this model. One of them is to be able to use the AI and digital twin to generate synthetic data for testing. And so my question is there any kind of validation and verification process to confirm that the generated data kind of match what already exists in real life scenarios?
So so there's a NERC model validation, I think MOD 003. So that's the one that we are going after. So whatever the output comes, it needs to go with the actual the flow or whatever. The synthetic data has to be within the model validation guideline, right? So that's how we will use the synthetic data. Does it make sense?
Yep, it does. Yep.
Okay.
Thank you. This is very great presentation for, and I always get I like the figures from NREL side for forever whenever there is a presentation. So if no other questions, I'll leave 1 more minute if anyone had any other question as an update.
Is it okay for us to ask a question?
You can always ask.
Just want to get a general opinion from everyone attending, if they are also using AI driven, and by AI I mean more of generative AI or otherwise the more newer or more visible platforms of technology in their product development or their research for any purpose. It's just for understanding what others are looking at and working on, if anyone can share.
This is a very great and hot question, I would say, specifically in the power system domain. If anyone would like to put insight on that, or anyone has an experience on this, that would be great.
Maybe I can start. Comet is using it, but not in a way of using the generative AI. They're using the artificial intelligence, different techniques to identify the different types of events. Again, they're looking at the real data coming out of their PMU stuff, and that's kind of AI I've seen in Comet and PG&E. But I don't know, the way you're looking at it is completely new, so it might be still evolving, I can say.
Thank you, Sanjeev. Any other comment?
Hey everyone, this is Hussein. Seung and other colleagues, thank you very much for your presentation. But with respect to this question, recently NYPA, New York Power Authority, basically gave us access for a ChatGPT version of NYPA that basically allows folks to, search for information. But the problem is that since it's disconnected from the internet and it has only access to NYPA documents, so far the outcome was not really that good. The cyber and IT team are afraid that if they connect it to the internet, the outcome becomes not really accurate because of the many different non-validated resources that exist on the internet. But this is still the first attempt and it's under test. But I would say it's I think there's still a long way to do it in a serious and use it in a serious manner. It's still in the preliminary stage and just under testing.
Thank you for sharing that, Hussein. I agreed. I think this is one of the things that it's a hard balance that we are also trying to find in our effort, especially with the local models, as in models that you would own and operate, and they would never leave your cloud, and how to get them to a stage where they are enough to meet your needs versus do you really need to rely on cloud services, and how do you balance that data ownership and privacy, other cybersecurity challenges. Thank you for sharing that perspective.
I think David has left already a comment saying that PNNL will be releasing a report on the use of ChatGPT for automating compliance testing in cybersecurity realm. So looking forward to that publication. If no other questions, I guess we're just on time. A kind reminder, we'll be sending another email for the next bi-monthly meeting, and we're gonna also be sending announcement on the annual meeting for the IEEE task force that's gonna take place in the general meeting this year in Seattle in July. Thank you, Dr. Shao and Rashid, for joining us and presenting these great efforts. Thank you, everyone, for joining us, and enjoy the rest of your day.
Thank you.
Thank you.
Thank you all.
Thank you.